Now, when we encounter e to the x forms in our integrands, we know how we can handle them. Now, this is not just e to the x, it's e to the 3x. So if we want an antiderivative, we're going to have an e to the 3x. Because the only way you're going to get an e to the 3x as your answer. However, if you differentiate e to the 3x, you get an extra 3 in part of your derivative. We don't need that 3 out there, that multiple of 3. We want a 4. Well, I'll keep the 4 there, but I'll have to divide by a 3. That way, I have the right derivative. If I differentiate this, I test it, I'll see that. Now, so that's one way you can handle it. Just sort of piece together the proper function, the correct antiderivative, just by piecing it together through your knowledge of derivatives and how to find a derivative. Now, the other thing you could do, and some students you'll have to do this in some cases, if you don't see this relationship, then you'll have to set u equal to 3x, then du is 3dx, and then that means that dx is 1/3 du, and then in your integrand you'll have a 4 e to the u times 1/3 du. Well, that's 4/3 e to the u du, which we know is automatically 4/3 e to the u, plus the constant, which I'll put on in a moment. 4/3, now u is actually equal to 3x, so I'm back to this anyway. So this is a full-blown change of variable. This is just noticing that over here, I did this, just noticing the proper form. Ideally, you'd want to be able to notice the proper form rather than have to go through this change of variable. But the change of variable is sometimes needed, so the mechanics of it are important to know and to be able to duplicate that.